Talk about central angles and arc measure. I'll get it back up there in a second. Sorry about this. It decided to freeze for some reason. So central angles and arc measures is what we're going to talk about today. We've already kind of given definitions, but we'll ease into the definitions just a little bit more. And then we're going to talk about how do we find different pieces of these arc measures given a central angle. And you're going to be asked to solve various types of problems dealing with central angles and arcs. So for reference, we draw this circle, and I do want you to draw this circle. Remember what we've talked about when we talked about on Monday, we did the different parts of a circle. So the different parts of this circle, remember that B is the center of the circle. We always label that with a capital B. And then the distance from A to B, okay, we called that the radius. That was labeled with an R. B to C then, that is also going to be a radius. And those two are going to be the same as each other. That 84 degrees, because that angle happens in the center of the circle, remember that's called a central angle. Okay, so I'm just going to kind of blast those two together, but yeah, let's get rid of that. Okay. So this is called the central angle. Now, the unique thing that central angle does is that central angle creates an arc. And we've talked about three different types of arcs in here. We talked about minor arcs, we talked about major arcs, and we talked about semicircles. So if you'll notice that if I put my finger on B, and I follow those two radii. Those two radii create this arc AC. So I'm just going to label that in a different, I'm just going to color this blue. And what we called that is we called that a minor arc. And when we labeled the minor arc, we labeled it with its two endpoints, and we put an arc over the top of it. Okay, and we'll come back to the meaning of that 84 in just a minute. The other arc that you'll notice that it creates is it also creates this arc in now red. Okay. We call that arc in red a major arc. We called it a major arc because it was over 180 degrees. And when we labeled a major arc, we started with A, then we kind of go around it, we get to D, and then we continue around it and we get to C, and we put a little arc over the top of it. Major arcs have to be named with 3 letters. Minor arc is 2. Major arcs are 3. We also talked about the whole distance around us. We talked about the degrees around a circle. Circle is how many degrees total? How many total degrees is a circle? If I start facing this direction and I turn all the way around, I've gone 360 degrees. Okay? So remember the total degree around a circle is going to be 360 degrees. Okay? That's the measure of the arcs completely around the outside of a circle. You often hear that, skateboarders are doing 720s or 1440s or 360s. They don't do 360s because that's not big enough anymore. But you hear those types of things. Okay. Now, the uniqueness about the central angle is that the measure of the central angle is exactly the same as the measure of the arc that it creates. So that's going to be our first little definition here. Well, we're going to do two. Well, let's do this one first. So the measure of the arc formed by the endpoints of a central angle is the same or congruent. So the measure of the arc formed by the endpoints of the central angle is the same. So if you know the measure of a central angle, you know the measure of the arc that that central angle creates. It's exactly the same. Okay, we also talked about the sum of the central angles in a circle. And we talked about a circle is 360 degrees. The central angles are going to be 360 degrees and so forth. So if we look at this drawing over here, arc AC right here, that arc measure is going to be the exact same thing as the central angle that created it. So if the central angle is 74 or 84, the measure of arc AC is also 84. So the measure of the arc is exactly the same as the measure of the central angle that it created. This part isn't in there, but we can do that. Okay. So what happens then if I extend this? I'm going to extend this side, and I'm going to create this angle right here. Can I find the measure of this angle right here?
It has to be 100.
Yep, these two angles, because they form a straight line, remember from Unit 2 back in October. Yep, it's created a semicircle. Very good. It's created a semicircle, but we've also created the same line. So I can find the measure of that angle right there by taking 180 minus 84. 180 minus that is 96 degrees. So if the measure of that central angle is 96 degrees, what's the measure of arc DC? 96 degrees. The measure of arc DC is also going to be 96 degrees because it has to be exactly the same as the measure of the central angle that it creates. Okay, so this is a lot of what we're going to do today. We're going to look at various examples where you're given a couple central angles or you're given the measure of the arcs that they create, and you're going to be asked to find kind of specific pieces. Okay, so let's look at a couple of examples. So let's look at this first one. Okay, so draw this first in your notes. It's nice that it's getting warmer outside, at least for a day. Tomorrow, I think they said the high is supposed to be like 35 tomorrow. Whew. Okay, so we have this circle, and I've got a central angle here that's 122 degrees. Now, on the other side of this paper, there's a bunch of questions. Okay, but let's see what we can fill out or figure out before I even look to see what our questions are. So, I know this central angle right here is 122 degrees. This angle right here. So this angle creates this arc right here. So if I follow to the end points, it creates this arc. So I know the measure of this arc right here has to be 122. Has to be. The measure of the central angle is exactly the same as the measure of the arc that it creates. Okay, if we just kind of keep looking at it then, we know this is straight, so that means it has to be 180. So the measure of this angle right here has to be 180 minus 122. 58. So the measure of this angle is 58 degrees. So what's the measure of arc SR? Measure of SR has to be 58 as well. They have to be the same measure. Well, there's one more thing we've got kind of sitting here, I guess, because there's lots of other things I guess we could look at. But do we know the measure of this arc right here? 180 degrees. Very good. It's a semicircle. So we know the measure of that is 180 degrees. Now, I haven't even looked at the questions yet. Okay, but we have really everything in here filled out that we could possibly get filled out. Okay, so let's look and see what the questions ask. So the first question says, find the measure of arc ST. Well, ST is from here to here. So the measure of ST is 122. The next one says, what is the measure of RS? Arc RS. R is here, S is here. So the measure of that is 58 degrees. The last one says SRT. Now, a couple things about this SRT. It's an arc. And I know it's an arc because it has the symbol of an arc over the top of it. So if it has a symbol of the arc over the top of it, you have to go around the circle. You can't cut through. A common error when you see something like SRT is to go from S to R over to T. You can't do that. SRT is this direction through R over to T. So we're looking for the measure of this whole arc. Well, how am I going to find the measure of that whole arc? Combine them. So combine means we're going to add, right? So if I take 58 plus 180, that's going to give me the measure of that whole arc, which is 238 degrees. Okay. So though we did everything first, then we answered the questions. That's one way to do the problems and the problems that you're going to do today. Let's look at another one. We're not going to do the next one. We're going to do a different one. Is everybody okay with this first one? Okay, let's look at another one. Guys, we're going to draw a circle. Obviously, we're in circle mode. So we've got this circle. Let's see if I can make this a little bigger. Okay, so we've got this circle. Probably too big. That's right. We're going to give it a center. We'll call it center W. I'm going to draw a radius here and here. And I'm going to tell you that this is 100 degrees. I'm going to put another one here. And I'm going to tell you that this is 150 degrees. I'm going to put another one here. And I'm going to tell you that this arc is 35 degrees. Now, we want to find, and let's label this. We'll label this S, V, U, and T. We want to find the measure of angle SWV. I'll rewrite this down here. This is 35. Can't really see that up there on my screen. Okay, we want to find the measure. So here's the second way to do these. And this is probably the way that I would do, in the way that I do these, is I put a plan together first and think about what we need to find. So I can put together a plan as to how I'm going to find my solution. So my solution wants us to find S, W, V. So we want to find essentially that W right there. That's what we want to find. So we know the distance around a circle is 360 degrees. Okay, so if I can find all of the arcs, because I know this is 100, so if that's 100, that means this is 100. If I know we've got the central angle that's 150, this is also going to be 150. And if we call this SWVW, we know that that has to be W. And if you notice now, I have that arc, this arc, this arc, and this arc. All of them added together, what do they have to add up to? 360 degrees. So that's what we're going to do. We're going to go W. So I'm just picking. I can pick anywhere I want. I'm just going to start at W, and I'm going to go clockwise. Plus 35 plus 100 plus 150. All of them together have to add up to 360 degrees. Okay. So 35 plus 100 plus 150, it's 250, 285. It's 285 equals 360. Subtract 285 from both sides. Hey Siri, what's 360 minus 285?
360 minus 285 is 75.
So the arc we just shown was 75 degrees. So if the arc is 75 degrees, the angle has to be exactly the same. So that's 75 degrees as well. And you're done. Okay. So in this case, we kind of put a plan together. Once we put that plan together, then we just went ahead and kind of executed it. Okay. Questions with that one? Okay, let's look at the next one. Again, we're going to draw another circle. Oops. I'm going to draw a circle, actually. Okay, so we've got a circle that's purple this time. I'm going to give it a center of, we'll call it Z. I'm going to draw this. And I'm going to draw this. And we'll call that R, S, T, and U. And now my question for this one is we're going to find the measure of arc S, T, R. Oops, we need something else. We probably need a measure at least of one thing, right? Let's say that this is 65 degrees. Okay, so I'm going to put together a plan first. I'm not just going to jump into this. I want to figure out what the heck I have to figure out. Okay, so I have to find the measure of arc STR. So I go to S. I have to go through T before I get to R. So if I look at my circle, I have to go this direction. There's T. Now I don't cut through. I have to continue around. So this is the arc that I need. Okay, so if I look what I know this is 65. I need to find the measure of this arc right here. And I have to find the measure of this arc right here. And if I can find all three of those arcs and add them together, I'll have my total arc. Okay, well, I know this arc is 65. So what does it make this arc right here, or this angle right here? 65. They have to be the same. So that has to be 65 degrees. You'll notice that SU, it's a straight line, right? So can we find the measure of this angle right here? What do they have to add up to? 180. So if I go 180 minus 65, it's 115. Jeez. That's 115 degrees. So if that's 115 degrees, that's 115 degrees as well. Now, we could do the same thing with these two angles here and here, right? They have to add up to 180 because they create RT, but we already know it. It's 115. Does anybody remember what we call those two angles? Starts with a V. It's when you're standing upright. You do this for a jump. Vertical. Vertical angles, and remember, vertical angles are congruent. Okay, so now I have what I need because I want to find the measure of this arc right here. So if I take 115 plus 65 plus 115, that has to give me that total arc. So 115 plus 115 is 230. 230 plus 65, 295. So the measure of that arc is 295. I can say 95, but write 90. 295 degrees. Questions with that one? Now, this stuff's hard. There's zero doubt about this stuff. This stuff is hard. I was talking to Mr. Leveson. Mr. Leveson's about a day ahead of us, which is generally what he is. He's a day ahead of us, and his class struggled with this a little bit. So he's actually spending another day on it today, but see if we can get through it. Okay, let's look at another one. So now, do we have the basic concept down? Does the basic concept make sense? Okay, so now the only thing we can do now is we can throw other things in there. We can start to throw variables in there. Okay, so we've got our circle. We're going to give our center of our circle. I'm going to put this and this. And I'm going to say that this angle right there is 90 degrees. I'm going to put this right here. And I'm going to say that this is 40 degrees. I'm going to put another line down here. I'm going to say that this is 85 degrees. And I'm going to put that this is 2x. Nope. Let's go 20x minus 5 degrees. So now we got variables in there. Oh gosh, no, not variables. Hate it when math throws variables in there. Concepts don't change. We still know the distance. We still know the measure around a circle is 360 degrees. That doesn't change. Okay? We want to find, we're going to solve for x. So our goal for this one is to solve for x. Okay, so I'm going to put a plan. I know this is 40. I know this is 85. I know this one over here, if this is 90, that's 90, right? So this makes this 90 degrees. If the measure of this angle in here, that central angle is 20x minus 5, what's the measure of the arc that it creates? 20x plus 5. Or 20x minus 5, I'm sorry. 20x minus 5. Do I have all of the arcs? Yeah, we have all of the arcs. What do all of the arcs have to add up to? They have to add up to 360. So I can just pick any spot I want to. I have a tendency to pick my variable one first. So 20x minus 5. Now I'm just going to go clockwise around it. Plus 85 plus 40 plus 90. I've got myself all the way around now. That has to equal 360. Just because there's a variable in there, it doesn't change the fact that around a circle is 360 degrees. The measure of the circle is 360 degrees. Now we just have to solve it. So we've got negative 5 plus 85 plus 40 plus 90. Hey Siri, what's negative 5 plus 85 plus 45 plus 90?
Negative 5 plus 85 plus 45 plus 90 is 215.
Did I say 45? Hey Siri, what's negative 5 plus 85 plus 40 plus 90?
Negative 5 plus 85 plus 40 plus 90 is 210.
Thank you. So 210 equals 360. How do I solve that?
By subtracting the non-variable.
Okay, so subtract 210 from both sides. So that's 20x equals 150. Divided by 20. We ask Siri, hey Siri, what's 150 divided by 20?
150 divided by 20 is 7.5.
Decimals are okay. We've now found the value of x. Using the concepts that we know and we understand. We know the central angle is the same measure as the arc that it creates. And that all of the arcs of a circle have to add up to be 360 degrees. Those things have to happen. And they always have to happen. Okay, let's look at the next one. So here's our circle. Purple again this time. We're going to go
I'm out of space.
like this. That one goes through the center. That's the center right there. It's really bad. So this right here is negative 4x minus 5. This is 85. And this is 50. We want to find the value of, we're going to solve again for x. So here's my drawing. See if you can solve this one for x. Again, keep in mind that this right here does go through the center of the circle. See if you can find the value of x. Can you take 4 minutes? We'll be done in 4 minutes.
Yeah. That's half circle, that's 180. Yeah, never think I'm wrong again.
Okay, so let's put a plan together. We have these 3 arcs. Here, here, and here. What do those 3 arcs have to add up to?
180.
They have to add up to 180. Because this right here is a diameter. So because that's a diameter, those 3 have to add up to half a circle, which is 180. So we're going to go 85 plus negative 4x, nice, plus negative 4x minus 5 plus 50, but this time they have to add up to 180, not 360 because it's only half the circle. If I wanted it to add up to 360 instead, I could just do plus 180 because we know the whole other arc is 180. You get the same exact answer. So we combine like terms. 85 minus 5 is 80. 80 plus 50 is 130. Yep. So we've got negative 4x plus 130 equals 180. We're going to subtract 130 from both sides. That's negative 4x equals 50. Divide by negative 4. X is equal to negative 12.5. If you asked Siri what 50 divided by negative 4 was, it would tell you. No, didn't hear me. Is it okay to have a negative number? Sure. Because it's negative 4 times negative 12.5. So a negative and a negative is going to give us a positive. So our arc would still say positive. That just becomes negative. Okay, and there's nothing wrong with that being a negative. Okay. Again, the stuff is hard. Biggest piece of advice I can tell you when you're doing your problems for today, set up a plan. Try to figure out what you're going to do before you actually do it. Then accomplish that goal today. Okay? The worksheet you're going to get today is only going to look at this type of problems. This is the sheet that you're about to get covers 2 days. This is going to cover both today and Monday. So keep this, don't turn it in, and you're only going to go through question number 10 on the worksheet today. So you're going to do 1 through 10 on the worksheet today. You do not need to do the whole thing. Come up here and grade it. Come up here and grab it. The answer key is up here. So if you want to look at the answer key to see if you're right on them, you can check that out. Again,